Hello, my name is Danny, and I'm an associate professor in the Department of Earth and Environment and also Department of Mechanical Engineering. I'm also an associate director of Initiative on Cities on the Urban Age, specifically focused on urban heat. I'm a climate scientist. More specifically, I'm a climate modeler. So the motivations for my research are threefold: climate change, urbanization, building energy consumption. I'm sure many of you have seen figures like this, which highlight how global Earth has been warming up and will continue warm up in the future. And more people are moving into cities, and cities are major consuming of the energy, especially in the building systems. I'm more looking at the interaction of all of these from different scales. Obviously, climate change is a global scale phenomena. Everywhere is warming up. Urbanization is more a regional phenomena that adds to the urban heat problem, as Patricia just showed. And a lot of the building energy consumption is also generating this anthropogenic heat flux, as also Ian showed, which will exaggerate the heat risk at local levels. So here I also want to highlight that for the global climate change problem, you are seeing figures like this from IPCC, where the historic climate can be constrained from observational data, but to really understand how the climate will change in the future, we need models like the ones that we use in our group, which range from global models to local models. Global climate models are essentially solving a bunch of equations that represent mass, momentum, energy conservation on grid cells that we use to discretize the Earth. And those grid cells tend to be very large, so we cannot really resolve cities in them. But in order to represent cities, we have to come up with like conceptual models to sort of represent cities in a computationally efficient but reasonable way into those models. But once we have those models, we can use those models to look at how climate change is going to interact with urbanization and affect the human population in cities. But a lot of the climate actions are actually happening not at the global scales, but at local scales. So the way that we approach this local scale action, such as the Chelsea work that Patricia showed, where a lot of the heat mitigation plans actually community driven that are really small scale. We use this approach called downscaling. So we go from global to regional, where we can look at impacts, and we can go even further. That's kind of like the really frontier of our research, that we can go to even local scales, where here you're looking at essentially the downtown Boston area, where on the left you're looking at the temperature, and on the right you're looking at the wind speed. These are super cool, computational fluid dynamics type of simulations that really allow you to essentially resolve the complexity of the urban environment at super detailed fashion. And with this type of modeling, we can answer questions like, what if you insulate the buildings? What if you paint roofs? What if you add, street trees in these areas? With that, I'll stop. And if you have any questions, I'm happy to talk to you after.